So every bit of information in our data stream represents a temperature, a pressure, a speed, a torque that's being monitored really closely by someone as nerdy as me sitting back in the factory. Well, we generate data from a variety of sources. Primarily, it's from sensors on the car itself. And those can be anything from measurements of physical quantities like temperatures, pressures, torques, speeds, right through to things like the operation of the system, so the internal state of all sorts of things on the car, like the gearbox. And those sensors are physically connected either through an analog system to the ECU on the car, the electronic control unit that runs the whole car, or through a series of network buses that we call CAN buses around the car that bring information back to that central unit. Well, if we take the total amount of data generated over the weekend by the car, including video and all sorts of ancillary information, it's probably close to 1 terabyte or even a bit more per car. But if you look at the really exciting bits of data, which are the live data generated by the car while it's running, we're looking at about 30 megabytes a lap of live data and 2 or 3 times more of that once the car is in the pits and we offload it.
There are over 250 sensors on the car during an average race weekend, and these can be divided into 3 main categories: control, instrumentation, and monitoring, all of which deliver pressure, temperature, inertial, and displacement data. These sensors are embedded into all systems on the car, and their size varies according to their function and type. For example, there is the FIA mandated TPMS system, which measures tyre pressures, and these are installed inside the wheels. In addition to this, we have small thermal imaging sensors mounted on the wings and floors to measure the surface temperature and degradation of the front and rear tyres respectively.
Track time in F1 is a very limited resource. We're not able to go back out and repeat a test if something goes wrong, so the pressure is really on to get it right the first time. Now this applies to the time we spend on track, the time we spend in the wind tunnel, and even the simulations that we do. So getting that data right the first time round is absolutely critical. And of course we have to balance the requirements of gathering the data for us, the engineers, against what the drivers need during a free practice session, because they're also trying to learn about the car, learn about the track, and set themselves up for qualifying. So once we've gathered up the data on the car, everything is synchronized, so we know exactly what's happening at a precise time on each one of those sensors, and the data is then encrypted and transmitted back to the pits through our telemetry system. Now the telemetry system is a common system across all the F1 teams, so there's quite a big infrastructure set up around the racetrack to make sure that we get pretty much 100% coverage, even at some pretty difficult racetracks like Monaco, where we're going through tunnels, or Baku, where there's a lot of reflections off some historic buildings. Now that system is common, as I said, to all the teams, so it's a pretty unique example of cooperation between the F1 teams. We used to set up our own masts, our own radios, our own telemetry systems, and we decided in the end that that wasn't the competition that we were really in. We want to be racing each other on track. There's no point in having a race between the guys setting up the antennas.
Most of us trackside, and the vast majority of other Formula 1 teams use a bit of software called Atlas, made by a company called McLaren Applied. So during a practice or a qualifying session, the drivers are very keen to see how their performance is comparing to their teammate. In particular, am I braking later? Am I carrying too much speed? Not enough speed? Is he turning in earlier than me? Where's he gaining that time? So going through that with the performance engineer is a key part of practice sessions, and in particular the qualifying session, when there's a short time in between runs, to try and understand where the key area of time loss is and where you can gain performance on the next run. So the driver's very keen to understand all this. But even away from the car and out of the car, particularly on, say, a Friday evening, they're particularly keen to review their own data, and certainly they are even more keen to get involved in loading their data and looking at it themselves, just to understand their performance, what they're doing, and getting an overall feel for what the car is doing, just to back up their observations and their feelings from within the cockpit. And of course, engineering groups around the drivers, we go through quite a bit of data with them just to help them understand what's happening in terms of the car performance compared to expectations with the setups that we're running, how the tyres are behaving and degrading during a long run to practice for the race, and other areas such as how they're operating various systems, So from my point of view as a control systems engineer, I'm primarily going through things like practice start performance with the driver, looking at the gear shift points to see how accurate he is compared to the optimum, assessing any switch changes and button functionality, and also the steering wheel dash display. And I can use the data to go through what the driver is seeing, and if he wants to see things in a slightly different way, we can then look at that, test it on the data. I can go through it with him, make sure he's happy with the change, and we can validate all of that before it then goes into the car.
We have a number of areas in the factory where the data is either generated ready for the race weekend or post-processed after the sessions. This includes places like our dyno, our simulator, aerodynamics and the wind tunnel, but also small individuals or smaller departments may post-process information specific to their area. The trackside electronics team will hand over the data from their on-car systems to the Formula One paddock team. We receive that data in the garage and then we pass that back through our systems to the factory. Your live data, such as on-car telemetry or voice or video calls. In a European event, those are within 10 to 15 milliseconds, so well under a second and almost instantaneous. As we move into the flyaway events, that can range depending on the actual distance from the circuit. So somewhere like Australia or Japan, we're looking at 300 to 400 milliseconds. We also have our offloaded car data and larger video files and media files. These take a lot longer, obviously, due to the size. We have an agreement with our engineering teams to prioritise that and to get it back to our factories as quickly as we can. This is expected to be before the car goes out for the next run. And as an example, during the Mexico weekend, we produced around 11 terabytes of actual data transferring backwards and forwards between the two factories and the event.
The rate of data depends on the sensor type and category, and this can range anywhere from 1 Hz to 1 kHz and can be increased significantly if we are interested in vibration data. For example, vibration data can be sampled up to 200 kilosamples per second and then goes through an intensive signal processing to filter the data down to sensible logging rates. F1 continues to push the limits of motorsport and deliver cutting-edge technology. It has become extremely crucial to provide reliable and accurate data to ensure success. As the car evolves, so do the sensing requirements, to such an extent that existing technology does not suffice. Therefore, the electronics department has had to develop bespoke sensors and data acquisition systems in-house to provide valuable information that can be used to improve the performance of the car and have a direct impact on the team's success.
So with sensors all over the car, we receive data from all aspects of the vehicle behaviour and the driver inputs and the driver performance. So for example, we can see exactly what the driver is doing in terms of braking inputs, throttle, steering angle, what buttons and switches he's changing on the steering wheel, and also overall car performance, so the aerodynamic performance from aero sensors, measuring pressure, performance of the power unit and the driveline. So with temperatures, pressures, all sorts of information that we can then use to understand what the driver's doing, what the car's doing, how it's behaving in the different ambient conditions and different cornering conditions around the track. So very useful information to understand what's happening out on track.
If we look to compare that to the sort of thing that we use every day, the amount of video, information, and data that we get off the car might only be equivalent to 2 or 3 people streaming high-definition video from their phones. But what's different is that every bit matters. So every bit of information in our data stream represents a temperature, a pressure, a speed, a torque that's being monitored really closely by someone as nerdy as me sitting back in the factory. So the electronics team has a pretty wide gamut of tasks. We're looking at things starting from the design of the electrical systems on the car. So we have folks back in the factory doing design of the looms, design of the overall system, and of course design of the controls that actually operate complex bits of the car like the hydraulics. And then in the end, that good work that's produced in the design and production of the car comes to us at the track. At the track, we're a much smaller team, really at the pointy end of that operation. And what we're doing is taking that good work and trying to make it run as reliably and safely as we possibly can. So that includes folks like our Sparkies, who are the technicians who build physically the cars and are wiring up the sensors and electronic parts of the cars. That includes our systems engineers, who are the ones calibrating the complex systems on the car and keeping an eye on their health while they're running. It includes control system engineers who are looking at the driver interface, the operation of the gearbox, the tuning and performance of the race starts and all sorts of other bits. And it includes specialists in areas like the radio systems. If we look for real-world comparisons for what an F1 car does and how we manage that data, possibly the best example would be something like mission control for a spacecraft. Of course, in many ways, our car is much simpler than that sort of system, but many of the same principles apply. We're still monitoring the health of a complex bit of engineering with hydraulic systems, electronic systems, and of course the interaction with the humans who operate that system. So in many ways, we're trying to do the same things. The data link from the car, again, is similar to the data link that you might have from a complex spacecraft. The bandwidth we now get from the car is probably thousands of times greater than it was for something like an Apollo mission, but of course, recent spacecraft are surpassing us by a long shot. We have the advantage, of course, that compared to a spacecraft, if something goes wrong with the race car, it normally just pulls over at the side of the track.